This is video note 6.2 for Math for Life. Hope everybody's doing well at home, trying to get this math done on their own. I'm really proud of you guys for returning the assignments that you have already. So let's take a look at what we're talking about today. Today we're talking about samples, surveys, and bias. You guys, I'm going to do a lot of talking today and very little math. So hopefully you guys don't mind that there's hardly any math in this section. It's really kind of just looking at sample surveys and bias and determining whether or not there is any bias or what kind of sample we're looking at. Anyway, so there's a lot of different sampling methods. There's actually like 6 of them on this note-taking guide. So we're just going to go through and we're going to talk about them. If we were in class, we would kind of do a little thing that would help you understand a little bit better, but we'll kind of just talk through it here. So the first sampling method is called convenience. A convenient sample is when you use people that you have access to. So you need to do a survey for your stats class. So you survey the 5 friends that you hang out with the day before. Or you set up a table at a mall and you give a survey to the people who walk by you. So convenience is exactly what that is. You know, you look for those people that are convenient around you, ask them the questions. That's called the convenient sample. Okay, so an example of that, if we were in class today, when you walked in, the first 5 people that came to class, I would have asked them, how did you travel to school today? Did you bus? Did you drive the bus, drive a car, walk, bike? What did you do? And because I asked just those first 5 people coming into class, I asked convenient people. This would be called a convenient sample. The next way that we can sample people is called a cluster. If there is some natural grouping occurring, you could select groups instead of selecting individuals. Our desks are in rows. Instead of selecting 4 individuals, I could select 1 row. And the sample would be all the members of the row. So a cluster sample would be like me saying today, let's take this container of Cheetos over here and let's just give them to every student who sat on the front row today. So because I am not picking all of you, I'm picking you according to something that's naturally occurring, like which row you sat in. That would be called a cluster. Okay. The next kind is called self-selected, selected, or voluntary. And that's exactly what it sounds like it's going to be. You literally just ask for volunteers. You could ask for volunteers verbally, on a flyer, via email, etc., anything like that. So it gives people the possibility of responding if they want to, or if they don't want to, they don't have to. Sometimes there's an incentive offered to get volunteers to participate. An example of that is you ask for the first 5 people to volunteer. How long does it take you to travel to school today? And you would just call on people who raise their hands. That would be asking voluntarily or self-selected. The next one is called simple random. This is where everyone has an equally likely chance of being selected for the sample. There is some randomizing process like drawing out of a hat or a random number generator, that kind of thing. So it says over here today, simple random sample, drawing your number out of a hat. How many letters are in your first given name? So if I put all of your names in a hat today who are in class, and I pulled you out of the hat and asked you that question, that would be a simple random sample. All right, systematic is the next one. Usually every nth person. What does that mean? It means you can determine what n value you want to use by thinking about the percent of the population you want to include. If you want 25% of the population, you would sample 1 out of 4 people, so the 4th person. If you wanted to include 10% of the population in your survey or sample, you would want to do 1 out of 10, so every 10th person. So today, if I wanted to ask every 5th person on roll call, did you eat breakfast today? And then you would have to answer that question yes or no. Then I just did a systematic sample because I picked the 10th or the 5th or the 2nd person. All right, the last sampling way is called stratified random. It's random, but also make sure that you have group proportions. So for example, if you wanted to sample the students from your school, you might want to make sure you had sophomores, juniors, and seniors represented in your sample. So today's stratified random sample says stratified by gender. You would want to make sure that you have the same number of male as female. And so you would ask, what is your eye color? So again, if we're going to do stratified random, we would do a random population, but we would make sure we have the same number of girls as boys, or whatever we wanted to determine as the item we needed proportionate. All right, so that's how we classify samples. Now for just a minute, we're going to talk about study types. There's 3 different kinds of study types here. One is called a survey, and we've all taken surveys before. Actually, they're kind of annoying when you get that little pop-up that says, do you have 5 minutes to take this survey? Well, surveys collect data. They do it by either written form or verbal form, where they ask you questions. Surveys are exactly that. We all know exactly what those are. Okay. The next one is called an experimental survey, or an experimental study. An experimental study is where you divide the sample into 2 groups randomly. One group receives a treatment while the other one does not. So for instance, if you were in like a drug testing sample, like they're trying this new drug for cancer, they pick 20 people to try the new drug or to be in the study, but only 10 of them take the drug and 10 of them take something called a placebo, which is the fake drug. So they do that. You don't know which group you're in, and they do the actual experiment to figure out, whether or not something's working. So that is what an experiment is. There's an example of that here. Giving one group of toddlers candy and the other group no candy. Compare the number of tantrums each group has that afternoon. So again, you picked a group and you only let half have something and half did not. The last way to study something would be called an observational study. It's where we're collecting data via observing or watching, researching. Members of the study are not affected by their participation. So for instance, studying the relationship between the ACT score and your success in Math 1050. Well, clearly there's a connection there, but the person that you're studying doesn't even really know you're studying them. So that's an observational study. Okay, so here's just a little chart that helps you remember all of those things. It's got those same examples typed throughout here so that you have them written down there. Then just the last thing that there's going to be some questions on your homework today is populations versus sample. Populations are all the members of the set, and sample are just part of that. So for instance, if I wanted to ask all of the members of Mill Creek a question, the population would be all of the members of Mill Creek. The sample would be the seniors at Mill Creek or the juniors of Mill Creek. So part of that entire group that I want to do my sampling or questions with. Okay. One more thing to talk about here, then we're finally going to get to some examples here. So the very third thing, the last thing we're going to talk about today here is bias. A sample has bias when a part of a population is overrepresented or underrepresented. A bias is a systematic error introduced by a sampling method. So if I wanted to know, for instance, who has the best hamburgers, would I ask people who are standing in line to get tacos? Do you see how that kind of is a biased question? You would want to make sure that you're asking questions that the population is not being represented or overrepresented or underrepresented in. So what we're going to do today is we're going to answer some questions. Still, guys, really no actual legitimate math here. We're just answering questions today about study types, bias, population versus sample, and sampling methods. So the first example here says, to survey the eating habits of the community. Oh, there's a typo. I'll have to fix that later. Employees of a local television station interview people visiting a food court at the mall. What sampling method are they using? So I think here, you guys, you probably could justify 2 different sampling methods here depending on the way you're thinking about it. At first I thought, oh, well, it's a food court. That's a natural grouping area. So I said, well, this could totally be a cluster. because that food court is a natural grouping of people already together. But then I thought, oh, wait, what if I just showed up at the food court and then I just started asking questions? I think that way, if we thought about it that way, that could also be a convenience sample. So I want you to know that on these, if you can justify to me an answer, if you don't have the same answer as me, if you can justify why, I think it's going to be all right on these. I think I would go with cluster, though, just because you've already gone to a place where people are already naturally grouping at the food court. The question is, does this sample have bias? So let's remember again what they're trying to ask and whether or not a group of people is being overrepresented. So does the sample have bias? We want to know about the eating habits of the community, and we go to the food court at the mall to ask questions. Well, doesn't that almost already tell us what kind of people or what kind of food habits we're going to be asking? Because we're going to the mall to ask about food habits, I'm going to have to say, yes, this does have bias. I think if you wanted to be unbiased, you'd have to ask at like the beach, maybe, where it's not a place that necessarily sells a ton of food, or someplace that, a park where you're not already getting people's opinion on food from where they're congregated at. I mean, food court mall, that means people are all right eating the food that's in a food court mall. All right, so let's look at the next question. Example 2. A maintenance crew wants to estimate how many of the 3,000 air filters in a 30-story office building need replacing. The crew examines 5 filters chosen at random on each floor of the building. Identify the sampling method. Well, I think this one could be a couple of different ones too. I thought, well, first of all, it said that they picked at random. So I totally think that you could go with simple random on this, because we're taking a random sample of what we already have here. So I think you go simple random. But I also thought about this one and I thought, well, isn't it systematic what they're doing? They're totally going to each floor and then choosing randomly. So if you would have picked systematic on this, I would have totally been all right with that too. Okay, does the sample have bias? I'm going to say this time it does not. You're going to every floor. You're picking a random sample. There is no bias in what's going on there with the air filters. All right, the last example here says, a pharmaceutical company asked for volunteers to test a new drug to treat high blood pressure. Half of the volunteers will be given the drug and half a placebo. The researchers will monitor the blood pressure of each volunteer. What is the sampling method? This is definitely, with no doubt, self-selected. Okay, they asked for volunteers. Volunteers means self-selected. And then it says identify the type of study method. Well, the type of study method would be, is it a survey, experimental, or observational? Because they're actually giving one group the medicine and one group not the medicine, this is going to be experimental. Because that's what experimental does, is where it gives the group half and half. And then the last one says, does this sample have bias? And I'm going to have to say no. I don't think that we've asked one group or not the other. We've been pretty equal about self-selecting, but they don't know whether or not they're being given the drug or not the drug. So there's no bias being formed here. All right, you guys, your homework's going to look really a lot like these examples. A lot of them are going to be multiple choice. Good luck. And if you have any questions, please give me an email. I would love to help. Thanks. Bye.